Hello viewers, welcome to today's session. Today we are going to discuss about the topic transfer function for mechanical, translational and rotational systems and how to find the transfer function with an example. So let us see the problem given. Obtain the transfer function for the mechanical system shown in figure. This is the mechanical system given in the problem. So for this mechanical system, if we have to identify whether it is a translational system or rotational system, we have to remember the basic idealized elements of the mechanical systems for translational and rotational systems. In my previous video, I have explained about the translational systems idealized elements. What are those? Mass, viscous friction and spring constant. So this is a translational systems. So for these translational systems, we will write the force balance equations. Before going to write the force balance equations, for any problem given, first step is to draw the free body mass diagram. This is the free body mass diagram for mass M. If there is one mass element, we will draw free body mass diagram for one mass element. If there is two mass elements represented in the diagrams, then we have to draw free body mass diagram for mass M1 and also free body mass diagram for mass M2 also. And mention the forces, all the forces acting on this mass element. How to represent these forces, that I will tell you. First, draw the mass element here and check whether the force is applied here or not. So F is applied inside, so I have mentioned F is applied to inside. And with the displacement is represented as arrow mark inside, so I have represented arrow mark inside. And when the force is applied, there will be equal and opposite forces act to that element. So for this mass element, the force due to mass itself acts opposite to this element, and force due to spring constant. Why? Because the spring constant element is connected to this mass, and viscous friction is also connected to this mass. So the force which acting opposite to this mass element due to spring constant, the force which is acting opposite to the mass due to viscous friction, and the force which is acting opposite to the mass itself. Definitely we have to represent this force due to mass itself for any kind of mass element, even though these elements sometimes may be represented here or not, but we should represent mass element force definitely. And later we will see what are the elements connected to this mass element that forces have to represent to that mass element in the free body mass diagram. Next, write all the forces equals to 0 according to Newton's laws of motion. For algebraic sum of the forces acting on the body or the system equals to 0. So force F of t applied equals to force due to mass plus force due to spring constant element plus force due to viscous friction. So for this force due to mass, force due to spring constant and force due to viscous friction, I have explained what are the equations for these forces due to each element in my previous video. You can see it. That is force due to mass element Fm equals to m into d square x by dt square. And force due to viscous friction Fb equals to b into dx by dt. And force due to spring constant k equals to k into x. Simply substitute in this equation. F of t equals to m into d square x by dt square plus b into dx by dt plus k into x. Now apply Laplace transform. When we apply Laplace transform, all the time domain functions will be converted into S domain. So Laplace of f of t becomes f of s. Laplace of m, we will, as it is, the value will be represented as m because it is not time varying function. And Laplace of d square x by dt square will be represented as s square into x of s. Plus Laplace of b, as it is b. And Laplace of dx by dt will be represented as s into x of s plus k into x of s. Why? Because displacement is only the element which changes with respect to time when the force is applied, and these are the elements which are constant, they will not changes with respect to time. So that is the reason I have mentioned B, M, K as the constant elements. And d square x by dt square, Laplace of d square x by dt square is s square x of s, Laplace of dx by dt is s x of s, Laplace of x of t means x of s only. So from this take x of s as common, ms square plus bs plus k equals to f of s. And just remind once the definition of transfer function. What is the definition of transfer function? It is the ratio of Laplace transform of output to the Laplace transform of input with all initial conditions 0. So this is the basic definition of transfer function. So based upon this transfer function, we will write the transfer function of this mechanical system given. So this is the equation. From this, according to the definition of transfer function, f of s is the input, x of s is output for this system, because from the diagram we can observe f is the applied input and final output displacement, x is the output. So transfer function equals to Laplace transform of output is the x of s to the Laplace transform of input f of s equals to 1 by m s square plus bs plus k. So this is overall transfer function for this problem.